Article 400.7b specifically allows the use of so-called as a drop from a busway. Article 400.8 starts out with the words unless specifically permitted in 400.7. So the question is whether running the drops under a raised floor is specifically permitted in 400.7. The answer to this question is yes, it is specifically permitted. Article 400.7b states that so-called can be used as a drop from a busway in industrial establishments where the conditions of maintenance and supervision ensure that only qualified persons service the installation. In this case, the installation is in a large facility with numerous labs, all having an overhead busway with pendants of so-called to feed the equipment. The so-called is terminated in a receptacle and all of the equipment is plug connected. The drops are supported and strain relieved in accordance with 368.8. The conditions of maintenance and supervision ensure that only qualified persons service the installation. Therefore, it is acceptable to have the drops run under a raised floor. Let's break down the relevant National Electrical Code, or NEC, articles to understand why this installation is permissible under specific circumstances. We'll begin with Article 400, which covers flexible cords and cables. This article outlines the general requirements and restrictions on the use of flexible cords and cables. It is crucial to understand that flexible cords are not intended for permanent wiring and have specific limitations on their applications. Article 400.7 addresses the allowable uses of flexible cords and cables. This section is key to determining whether a particular application is permitted by the NEC. Specifically, 400.7b allows for the use of flexible cords for pendants. A pendant, in this context, refers to a cord that hangs down from an overhead power source, such as a busway, to supply power to equipment below. The allowance for pendants is subject to certain conditions, which we will discuss later. Article 400.8 lists the prohibited uses of flexible cords and cables. This section outlines situations where flexible cords are explicitly not allowed. The introductory phrase unless specifically permitted in 400.7 is critical. This phrase means that if an application is specifically allowed in 400.7, it overrides the restrictions in 400.8. Now let's delve deeper into the specific requirements of 400.7b, which permits the use of so-called as a drop from a busway. The key phrase in industrial establishments where the conditions of maintenance and supervision ensure that only qualified persons service the installation is paramount. This phrase establishes two critical conditions that must be met for this allowance to apply. Firstly, the installation must be in an industrial establishment. An industrial establishment typically refers to a facility used for manufacturing, processing, assembling, or other similar activities. Laboratories, especially those with sophisticated equipment and specialized power requirements, can often fall under this definition. Secondly, the conditions of maintenance and supervision must ensure that only qualified persons service the installation. This requirement means that the facility must have procedures in place to ensure that only individuals with the necessary training, knowledge, and experience are allowed to perform maintenance, repairs, or modifications to the electrical system. The rationale behind this requirement is that qualified persons are more likely to be aware of the potential hazards associated with the electrical systems and to follow safe work practices. This reduces the risk of accident, electrical shock, and fire. In the scenario presented, the installation is in a large facility with numerous labs, all equipped with overhead busways and so-called pendants. This suggests that the facility could indeed be classified as an industrial establishment. Furthermore, it is stated that the conditions of maintenance and supervision in this facility ensure that only qualified persons service the installation. This indicates that the second condition of 400.7b is also met. With these two conditions satisfied, the use of so-called as a drop from a busway is permitted. The remaining question is whether running these drops under a raised floor is also permitted. To answer this, we must again consider the relationship between 400.7 and 400.8. Article 400.8 prohibits the use of flexible cords where attached to building surfaces or run through holes in walls, structural ceilings, suspended ceilings, or floors. However, because 400.7b specifically allows the use of so-called as a drop from a busway under the conditions described as allowance overrides the general prohibition in 400.8. In other words, if an application is specifically permitted in 400.7, it is not subject to the restrictions in 400.8. Therefore, because the use of so-called as a drop from a busway is permitted under 400.7b, and the conditions of maintenance and supervision ensure that only qualified persons service the installation, it is also permissible to run these drops under a raised floor. This is provided that the installation meets all other applicable requirements of the NEC, such as those related to support, strain relief, and protection from physical damage. Article 368 provides requirements for busways. It's relevant because the so-called drops originate from the busway. It's essential that the busway itself is properly installed and maintained, and that the connection points for the so-called drops are suitable for the purpose. Section 368.8 addresses the support of busways and associated equipment. The so-called drops must be properly supported to prevent strain on the busway connections. Section 368.56 covers overcurrent protection for busways. This ensures that the busway is protected from excessive current that could damage the equipment or create a fire hazard. In addition to the requirements of Articles 400 and 368, it is also essential to consider the requirements of Article 645, which covers information technology equipment. Article 645 addresses the specific electrical requirements for IT equipment, including power distribution, grounding, and bonding. If the lab equipment in question falls under the definition of IT equipment, then Article 645 would apply. Section 645.5 permits the use of flexible cord and plug connections for IT equipment, provided that certain conditions are met. These conditions include that the cord does not exceed 15 feet in length, that the receptacle is readily accessible, and that the cord is protected from physical damage. Section 645.10 addresses the wiring under raised floors. It specifies that the wiring under raised floors must be listed for the purpose or be contained in raceways. However, there is an exception for flexible cord and plug connections that meet the requirements of 645.5a. This means that if the so-called drops meet the requirements of 645.5a, they are not required to be listed for use under raised floors or to be contained in raceways. However, it is still important to ensure that the cords are protected from physical damage and are properly supported. Article 300 contains general wiring methods. Several sections within Article 300 are relevant to this discussion. Section 300.4 addresses protection against physical damage. It requires that wiring be protected from physical damage, whether by location, raceways, or other means. This is especially important for so-called drops that run under raised floors, as they may be vulnerable to damage from foot traffic, equipment movement, or other hazards. Section 300.11 covers securing and supporting wiring. It requires that wiring be securely fastened in place and supported at appropriate intervals. This helps to prevent strain on connections and reduces the risk of damage to the wiring. Section 300.14 addresses the length of free conductors at outlets and switch points. It requires that a sufficient length of free conductor be left at each outlet or switch point to allow for proper connections and future maintenance. This is important for so-called drops that terminate in receptacles, as it ensures that there is enough slack in the cord to make connections without straining the conductors. In summary, the use of so-called drops from busways under raised floors is permissible under specific circumstances, provided that the following conditions are met. Firstly, the installation must be in an industrial establishment where the conditions of maintenance and supervision ensure that only qualified persons service the installation. Secondly, the so-called drops must be properly supported and strain relieved, in accordance with 368.8. Thirdly, if the lab equipment falls under the definition of IT equipment, the so-called drops must meet the requirements of 645.5a. Fourthly, the so-called drops must be protected from physical damage, in accordance with 300.4. Fifthly, the wiring must be securely fastened in place and supported at appropriate intervals, in accordance with 300.11. Finally, a sufficient length of free conductor must be left at each outlet or switch point, in accordance with 300.14. By adhering to these requirements, it is possible to safely and effectively use so-called drops from busways under raised floors in industrial establishments with qualified personnel. It is important to note that this analysis is based on the information provided and the specific requirements of the NEC. Other codes and standards may apply depending on the location and nature of the installation. It is always recommended to consult with a qualified electrical professional to ensure that any electrical installation complies with all applicable codes and standards. Additional considerations should be taken into account when implementing this type of installation. Firstly, consider the ampacity of the silk cord. The silk cord must be sized appropriately to handle the load it will be carrying. The ampacity of the cord is determined by its gauge and temperature rating. It is essential to consult the NEC ampacity tables to ensure that the cord is properly sized. Secondly, consider the voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or overheat. The voltage drop in the silk cord must be within acceptable limits, as specified by the NEC. Thirdly, consider the grounding and bonding. Proper grounding and bonding are essential for electrical safety. The equipment grounding conductor in the silk cord must be properly connected to the equipment and to the building grounding system. This helps to ensure that any fault current will be safely conducted back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Fourthly, consider the environmental conditions. The silk cord must be suitable for the environmental conditions in which it will be used. This includes temperature, moisture, and exposure to chemicals or other substances. If the cord will be exposed to harsh conditions, it may be necessary to use a special type of cord that is designed to withstand those conditions. Fifthly, consider the maintenance and inspection. Regular maintenance and inspection are essential to ensure that the installation remains safe and reliable. The silk cord should be inspected periodically for signs of damage, such as cuts, abrasions, or fraying. Any damaged cord should be replaced immediately. The connections at the busway and at the receptacles should also be inspected to ensure that they are tight and secure. Sixthly, consider the documentation. It is important to maintain proper documentation of the installation. This includes drawings, specifications, and maintenance records. The documentation should be readily available to qualified personnel who service the installation. Seventhly, consider the training. Qualified personnel who service the installation should receive adequate training on the proper procedures for working with silk cord and busway systems. This training should include instruction on the potential hazards associated with these systems and the safe work practices that must be followed. Eighthly, consider the coordination with other trades. Coordination with other trades, such as mechanical and plumbing contractors, is essential to ensure that the silk cord drops do not interfere with other systems. This is especially important under raised floors, where space is often limited. Ninthly, consider the future expansion. When designing the installation, it is important to consider the potential for future expansion. The busway system should be sized to accommodate future loads, and the silk cord drop should be arranged in a way that allows for easy modification or addition. Tenthly, consider the energy efficiency. Energy efficiency is an important consideration in any electrical installation. The silk cord should be sized to minimize voltage drop and energy losses. The equipment that is powered by the silk cord should be energy efficient as well. In conclusion, the use of silk cord drops from busways under raised floors is a complex issue that requires careful consideration of the NEC and other applicable codes and standards. By following the guidelines outlined above, it is possible to safely and effectively use this type of installation in industrial establishments with qualified personnel. However, it is essential to consult with a qualified electrical professional to ensure that any electrical installation complies with all applicable codes and standards. Always prioritize safety and follow established best practices to prevent accidents and ensure the reliable operation of the electrical system. Remember to stay informed about the latest updates to the NEC and other relevant codes and standards, as these regulations are subject to change.